I hope you can hear me. Mm. Okay, okay, okay. Does it show like how many? Okay. Okay. What a pen. I hope you can hear me right now. Okay, let me just fix the volume over here because I think my audio is low. Mm, I hope you can hear me, guys, because I don't know what's wrong with my audio over here. Uh, I'm about to start now. So okay. So basically, I will start with is what is it? The one which is about the. Let me check on my question paper over here. Okay, I'm trying to. Let me see. Google Drive. Upload device. My device. Yeah. So basically, we'll start by revising everything, then head over to the questions because I think there are things on my notes which are more important and helpful, right? So basically, let me just upload. Oh, that's paper one, that's paper one, that's paper one. Ish, I'm so, yeah. Okay. If my audio is a problem or it's low, now please let me know so that I can fix that. So this is the last push. I really recommend this document because basically it has almost every questions you will need. Come in. This is for paper 2. Yeah, it's paper 2. Okay, I think we can start now. So basically, guys, the other thing that you need to do is when you study, use what's this, what do you call, the study, I'm sorry, was my chalkboard over here? Okay, let me just get my marker and start with it. I can see I only have one view. Please comment over there if you have like a specific problem. Maybe I can help you straight, rather than wasting your time. mm. Gosh, I lost my marker over here to write on the board. Okay, I got it. Where are my notes? Please be patient with me. So I, okay, yeah, it's the ones which is about the galvanics, right? So I'm back. Okay. Yeah, so let's, so basically one of the things that you should know is that they are called voltaic cell. That's the other name for what, for the galvanic cell. So let's start on the, so basically for you to more like understand the concept, you have to ask yourself the three whys, which will be: what is the purpose of electrochemistry, what is electrochemistry, and why should I study electrochemistry? Now let's look at the electrochemistry. If we start by electrochem, so basically when we are talking about electrochemistry, we are just talking about the study of what, of the relation between chemical reaction and what, and electricity. So basically we use it mostly, let's say you have a battery and on a remote, right? So basically that battery will work for a long period of time. So why doesn't it run flat fast? It's because of the electrochemistry, because basically it can reproduce the power which has been given out to the remote, right? So basically what is the purpose of electrochemistry? It is the ability to make the electric current using what, the redox reaction. So basically electrochemistry it's used mainly for what, for making, for current what, uh, using redox. So basically why should you study the electrochemistry? So basically one of the main point or main important things about electrochemistry is that it can remove what, corrosion. Please forgive me because I'm not a teacher, I'm just a student. I'm just trying to share my knowledge with you. So basically now I want us to go straight on the galvanic cell. Let me not waste your time over here, right? So let me just remove everything here which is not related to what we are doing over here. So now let's start with our lesson of the day. Basically it's just a revision, so please comment over there if you're having any problem. So let's start about the galvanic cell. So one of the things is that this is an exothermic reaction. It is exo reaction, meaning that our delta H, I'm sorry, let me just redo our delta H over there is greater than, it's less than 0. That's our exothermic. So basically here on galvanic cell you must know that it is the energy conversion from what, from chemical to what? To electrical. So the other thing that we should talk about is the oxidation reduction in terms of what? In terms of galvanic cell. So basically, let's go straight on the oxidation. When we talk about oxidation, we are talking about the loss of electron or the increase in oxidation number. Basically, if we have a HCl, maybe what can I say? I'm just making an example, plus H, right? Then basically you go over there and have something like Cl minus, and here let's just see it is plus, and here it's H2, right? So basically the oxidation, it is the loss of what? It is the loss of electron, meaning that this one lost an electron and gave it to this H and it became 2. So when we say it is the increase in what? In oxidation number, basically over here, I'm sorry, it is not minus, basically here it is going to be only positive. So I don't think I explained that in an let me just remove it. I'm back at home, guys. Yo, there's noise, I can't concentrate. I'm sorry for the noise. Please bear with me. So guys, one of the things that I want you to do is that if you don't understand, ask me to start again, because basically you have to understand. Oh, kind of having a problem over here. So I want us to talk about the, what's this? Is the oxidation and reducing in terms of galvanic cell. So I got a question there. They say please repeat. Okay, I'm repeating, right? So basically I don't think I'm repeating, I didn't explain it bad, but I'm going to do right now. So let's talk about it's oxidation. So this is the loss of what? Of electron, but it is the increase in oxidation number. So basically if you have maybe a Cl, there's a Cl, maybe minus, okay? So basically let's say it's HCl. When we say an increase in oxidation number, this over here, let me change a color to make you see the difference. This is the oxidation number, number. When we say you lost an electron, what we basically mean is that maybe this is an electron, which is H and Cl. Basically if we have an HCl, and we have Cl plus and plus H, when you say you lost an electron, basically this is it disassociated completely, meaning it separated completely. Now since since HCl lost an electron, it means it is going to increase in what? In oxidation number. That's why they say oxidation is the loss of an electron, but an increase in oxidation number. Now let's talk about an oxidizing agent. What is an An oxidizing agent is a substance that gains an electron and undergo reduction. So basically, if we are talking about an oxidizing agent, it is more like the reduction. Yes, it's about reduction. Since reduction, it is the gaining. So basically, if we are talking about the agent of oxidation, not oxidation agent, but it's the oxidation's agent. Let me just uh, yeah, let me, it's oxy I'm kind of having a problem here. Yo guys, let me have this motherboard that I'm using over here. It's kind of not doing well. Okay, now I wanted us to talk about the oxidations oxidation agent. Please note that I didn't say oxidation agent. I said the oxidations agent, meaning that the agent of oxidation. The agent of oxidation is what? It's a reduction agent or reducing agent. Why is a reducing agent the agent of oxidation? It is because an reducing agent, it loses electron and undergo what? Oxidation. So basically what I'm trying to say over here, let me just this is what I'm trying to say, guys. Yeah. No connector t connector nil download eh so oxidation, I'm sorry about that. Oxidation, it has its agent which is reducing. Why is oxidation agent not oxidation agent? Oh, I'm sorry, kind of fumbled on that one. Guys, please note I'm not a teacher, right? I'm trying to explain everything in a simplest way. So oxidation has an agent which is called a reducing agent, because this reducing agent, it loses electron and it undergo oxidation. So basically the agent of oxidation is the reducing agent, right? Now let's talk about what do you call this? I hope I'm not bad, guys. Okay, let's talk about the reduction. This is a reduction in terms of what? Of galvanic cell. Now what is a reduction? Reduction, it is the opposite of oxidation, which is the gaining of electron, and also what? The decrease in oxidation number. So let's say we had that HCl that we were talking about, and we go over there. So basically what happened, we gain an electron. So let's say we have an HCl, let's say it's H2Cl. Let's say here we had an H and a plus. So basically what happened is that this HCl, it gained an electron. Which electron? The hydrogen. But it decreased in oxidation number, because when we gain an electron, our oxidation number, it increases. So basically we had one, but now it's two. These two, it just mean that, so okay, let me just I don't want to make this kind of difficult. I want you to understand that over here we had like since it is gaining and reduction, we had a -1. So this -1, it means that this Cl had a 1H electron. It was 1H electron. Now when we gain another H electron, it becomes 2. So basically we gained an electron, but our oxidation number, it decreases. As you know, obvious, we have 0, we have 1, we have 2, we have -1, we have -2. From -1 to over there, we are decreasing. We gained an electron, which is hydrogen, but we decreased in oxidation number. Now let's go straight to our table of what? Of galvanic cell. Let me just I hope guys I'm not bad. I'm really trying. So basically if you have like a certain problem, please tell me, because I don't think I'm I'm a good teacher guys, because as you can see I'm kind of struggling, but I'm trying. The problem is that I'm understanding, so I just want everyone to understand in the same way I'm understanding, you know. Okay, let's draw this table over here. Is it a table or whatever it may be? Let's see, we have our, what is this? They call it the salt bridge. Then we have our electrode over here. It's not straight, right? I'm trying, people. And then we have our, what's this? Voltage cell. Me and drawing, we are not. Let me just redo this, because if I don't draw it correctly, I'm going to have a problem. So let's talk about the this is our electrode over here. Eh. Now we have our salt bridge. Then after salt bridge is the voltage cell. J. When Saturday? Positive and negative. Basically, this is a cathode. I'm sorry for that. Okay, let me just repeat this over here. I hate being home because now I'm being disturbed while I'm doing my tutorials over here. I'm sorry guys for that. Okay, we have our voltage cell over here. So basically, in terms of galvanic, you must know that whenever we have a positive, it is what? It is a cathode. Meaning here, it is a cathode. And here as a negative, we have what? We have an anode. Now this is our salt bridge. And this is a half cell. Even this one, it is a half cell. Inside here, it is a solution, right? It is a solution. So basically, let's start by talking about everything which is here. So you must note that our current flow from what? From the anode to the cathode. Basically, our current will flow from what? From negative to positive, meaning that this is the direction of. So what does the salt bridge do? What it does is to complete a circuit. What is to complete a circuit? Basically, if here we have more ions of a, let me say it's HCl, and we have Na. So if we have an excess of ions of a certain molecule or atoms, which is basically maybe HCl or Na, the salt bridge, what it does is to make sure that this excess molecule or the excess ions which are left, they are neutralized. Basically, we have equal amount of Na HCl on this side, and that NaHCl on this side. Basically, we don't want to have an excess of a certain molecule on each side of what? Of half cell. So what it does is to neutralize the what? Is to neutralize the ions. Now let's talk about what? Let's talk about the cathode. Now when we talk about the cathode, this is where reduction takes place. Now when we talk about an anode, this is where an oxidation takes place, right? So let's move on to our standard hydrogen electrode. So let me draw. Oh no. Why is it so small? Okay, I just fixed my have this beaker, and we have also this beaker, but this one contains of a platinum. So basically, most of the time you may find out that the hydrogen or the platinum half cell, it is an anode. So it's not always an anode, it can be a cathode and also an anode. So let me just complete this line. This is our V over there. I kind of think I'm actually nervous of teaching here online. This is our solution. Alright, okay. Now, so basically let's start about the, oh, I'm sorry, I forgot the salt bridge over there. We have to complete the circuit. Yeah, my drawing is bad. This is our salt bridge. So basically, why do we use let me just remove this message over here. What do we use the standard hydrogen electrode? So basically we mostly use this to determine the ability of an electrode to what? To accept or reject. No, it's not reject, it's to give the electrons. Oh, so or to give so we use the standard hydrogen cell electrode to determine the ability to accept or give the electron. But why do we use it, not other? Because we don't have only the, what is this, the hydrogen on our cell voltaic cell table. Let me just, if you go to that table on your last pages of the question paper, you will find out the potential difference of the H, it is equal to 0,00 V, meaning that this electrode cannot be influenced to undergo a reaction because it doesn't have anything to give out. So it determines the ability of another electrode to give or accept the electron. Let's say here we have an, let me open the back of my question paper over here and choose any of the half reaction. Now I met this one, it's lithium. Let's say here we have a lithium. Yeah, let's say this is a lithium half cell half. So basically we want to determine the ability of it to accept or give an electron. So what happened is that we go over here and look for our, how do we determine the ability of it to accept or give electron? Basically we just look for our E node, which is equal to E cathode minus E anode. Now how do we know if this which one is an anode and which one is an electrode? Basically I wouldn't talk about the negative and positive. Here is what I'm going to talk about. When we talking about the electrode, the anode or cathode, a cathode happens to have a less voltage. A cathode has a high voltage than what? A cathode has high voltage than what? Than anode. So how do we know of that? So if we go, since we know that we have an H over here and here we have a lithium, just go back to your, what is this, the standard reduction potential table. If we look at an hydrogen, you will find that the potential of a hydrogen is 0, 0, which is 0, 0, 0, and a lithium potential is negative 3,05, negative 3,05. Now basically if I ask you which one has a greater potential difference, you will find out that the H has greater potential and the lithium has the less potential, meaning that since H has a higher potential, our H over here is what? It's a cathode, and here our lithium is an anode. But basically if you have two, which mostly you will have the first one as a positive and a negative, you already know that the positive is cathode, the negative is what? Is the anode. But when you have the same sign, more like a negative and negative, you just have to look which one is greater and give it cathode. If you have positive and positive, you have to look which one is greater and give it the what? The cathode. So basically since this one is it will be a minus. So I don't know what else should I go through. Okay, let's go through the electrolysis or the electrolytic. Okay, let me just remove this. So when we talk about the electrolytic, we are basically talking about the opposite of what? The opposite of galvanic. But let me just write over here. We have an electrolytic cell. Since I said the galvanic is exothermic, this one is endothermic. Let me charge my PC, guys, before I have a problem. charged my PC. Back. Oh,